I am adding this video to this playlist with a few comments on linear integer programming, which is a specific area within linear programming, because I want you to know that sometimes we need integer variables, sometimes we just have integer quantities, and we need to reflect that. For example, we have to decide how many trucks we send from a location to another one, and we are not managing numbers that we can round. So imagine we have to send either one or two trucks, so we need to reflect that in our model. We don't accept values like 1.5 trucks because we are actually sending actual trucks, and that means sending either one or two or just none. And other times we have binary decisions. We do something or we don't do it. And that requires binary variables. For example, we might be designing our supply chain network, and we might locate a new facility in a location or not. So it's either we locate that facility or not. There's nothing in between. So that requires a binary variable, 0 or 1. Okay, we don't have the possibility of installing two-thirds of a facility, and that is not something that makes sense for the decision maker. In terms of the model, what we had so far is a feasibility region when we had two variables, which is the simplest example, where we had a set of constraints which were straight lines, okay, which defines the feasibility region that we colored in orange in the apparel manufacturing company example. And any point here within that area is a feasible plan, which is something we can put into our manufacturing plant and get whatever we have decided. So those points out of that orange region are feasible solutions. Those are solutions that, though we might like them, we cannot do what they suggest in terms of production. Any point around here would be production plants where we're producing far too many shirts and plants. But we might request from our model, from this model or whatever model we are dealing with, to have integer variables. And that means that the feasibility region is now no longer the full area, but only those points corresponding to integer variables, which are those indicated in orange here. So we have an infinite number of solutions in this area, and we have a finite number of solutions here, which are only those dots that are in orange. Those that are gray are invisible integer solutions, so we're not interested in them. So we go from an infinite number of solutions to a finite, but the paradox is that these problems are more difficult to solve. The larger the number of integer variables, typically the more complex it is to solve, and the more time it takes for the solver to get a solution, because as I'm going to comment, methods are more complex and they take more time. But first I want to highlight that rounding is not an option. Sometimes it might be if we are dealing with very large numbers, and we might round it, and the error we make when we do that rounding, it's similar to the error we have in the input data. Well, might be okay, but when we are dealing with more accurate representation of our decision, that is not an option. As I said, if we have 0.3 trucks as an outcome of our model, that doesn't mean anything. We cannot call our supplier, the transport company that delivers our products, and ask him to ship only 1.3 of the truck. Well, we can do that if that means the capacity of the truck, but if we're talking about actual trucks, you send one or you don't send any. And to obtain those integer variables or integer values for our variables, that means using solving methods which are more, let's say, complex. They require more computational time, and solving times are larger for a given problem size. So if we have a problem and we turn some or all of the variables into integer variables. But for some specific problems, the case is that the time to solve them is larger. And finally, the sensitivity analysis that I briefly spoke about in a previous video has to be done manually. We cannot have the possibility of getting that information automatically. Okay, that is for you to know that integer problems are more complex, although sometimes we have to represent our system in terms of integer or binary variables because there's no other way to get a solution that we can make use of, but if we do that. Okay, thank you very much.